Greetings, ladies and gentlemen. Welcome to our first lesson in Unit 3. And as you can probably notice, this lesson is not in your Big Ideas book. Ladies and gentlemen, we are going to travel back in time and we are going to recall and remember some things about very important angles that will help us moving forward in Unit 3. And that means we are going back to last year's Big Idea book, which is Lesson 7.1 and Lesson 7.2 from your 7th grade Big Ideas book, which deals with adjacent, vertical, complementary, and supplementary angles. So we are going to remember what we learned and recall by identifying adjacent, vertical, complementary, and supplementary angles. Our essential question: can adjacent angles be vertical? Can adjacent angles be complementary? Can adjacent angles be supplementary? And we will remember that if you don't already. But we're going to spend some time. So ladies and gentlemen, if I do not mention this, I would be remiss. It is so important. Put your pens, pencils down, everything like that, and then watch and recall and listen, and then pick up your pens and pencils after you pause and write it all down. So let's go to adjacent angles, ladies and gentlemen. Adjacent angles, two angles which share a common side and have the same vertex. So the first thing I'm going to do when I come over to this picture over here is I am going to highlight my vertex, and I'm going to highlight it with my black dot. That is the vertex. As you can see, those two intersecting lines do form four angles. Angle 1, 2, 3, and 4, based on how this is labeled. And those four angles do have a plethora. Well, I wouldn't use that word, but they have quite a few. Let's call it four sets of, or four pairs of adjacent angles. Let's do the first one. The first one's going to be done with red. So I'm going to highlight that side. That means there are two of those angles that share that black vertex and that red side. And as you can look, you can see angle 1 and angle 2 share that side. Going with green, I'm going to highlight this side here. And there are two angles that share that green side. That'd be angle 2 and angle 3 and the vertex. So they are also adjacent angles. Moving on. Going down, I have two angles that share the purple side and the vertex. That's angle 3 and angle 4. They share the purple side. And lastly, I know it's difficult to see, but I'm going to choose let's go with the dark blue. And I'm going to come this direction. It looks kind of black, but it's really dark blue. And there are two angles, angle 4 and angle 1, which share that side. So this particular figure shows four pairs, four sets of adjacent angles. Let's talk about our vertical angles. Vertical angles which are formed by the intersection of two lines. This is what we have here, two lines that intersect. Vertical angles are congruent. If you remember the congruent symbol, it is a wavy line with an equal sign under it. That is what congruent means. Right there, congruent. Okay, there's something I want you to add to this, and that would be, don't add it right now, add it when we're done and you pause and watch, that vertical angles do share a vertex. They do not share a sides. Okay, so they share a vertex, but they do not share sides. So, in taking a look up here, I'm going to take my marker and I'm going to put these opposite angles 2 and 4 that I just put a black mark in. So those two angles are vertical. They share the black vertex and they do not share a side. So angle 2 and angle 4 are vertical, which means they are congruent. Okay? And lastly, well, you can't really see yellow, so let's go with red. I'm going to use red. I'm going to do this one up here and this one over here. The other set of opposite angles which share a vertex but not a side, formed by intersecting lines, angle 1 and angle 3 are also vertical angles, and they are congruent. Ladies and gentlemen, let's put this to practice, remembering what we're doing. Got a little bit crazier picture here. It says use the figure to identify a pair of adjacent angles. And I see here that we have two sets of, or two intersecting lines, and then we have one ray. And it makes it look kind of crazy. Now there are multiple pairs of adjacent angles here. It doesn't matter which one we choose. But what am I going to do? I am going to highlight the vertex because I know adjacent angles share a vertex. And then I'm going to highlight a side. Let's highlight this side right here. I'm highlighting that side. So what do I want? I want the angle that's on the one side, and I want the angle that's on the other side. Okay? So I have angle FBA, and I have angle ABC. Now, ladies and gentlemen, one very important thing that we need to recall when you are labeling angles in such a way, because they have more than one point, that the vertex is always in the center. So I could write this angle FBA, I could write angle ABF. That is the same exact angle, but again, the vertex must stay in the center of your labeled angles. So there are multiple other adjacent angles in this picture, and we will revisit that in class tomorrow. Moving right along to vertical angles, and again, here we have 3 intersecting lines. And of course, they all intersect at this vertex. So I know that vertical angles do share a vertex. They do not share a side. So what I'm going to do is I'm actually, now that I've highlighted, I'm going to just copy over 2 lines. I have that one and I have this one. The other one I'm going to now ignore. And I'm going to connect. I have this angle here. And what angle is opposite of that one? That is correct, over here. Because they share the vertex, but they do not share a side. So now when I label that, I have angle Q, J, and N, and angle K, J, and M. Those are 2 vertical angles, which means they are congruent. Now there are others. In fact, there are others directly related to what I drew. I could do this red angle here and that red angle there, because they use those 2 lines. They share the vertex, they don't share a side, and they are opposite. But since there's another line in there, I could create other vertical angles. And again, we'll talk about that in class. All right, if angle PJQ is 85 degrees, what is the measure of LJM? Well, let's take a quick look here. I'm going to erase that so I can highlight. Angle PJQ. All right. Oop, sorry, wrong one. I'll use red. PJQ. Right there, PJQ, and that is 85 degrees. It wants to know what is the measurement of angle LJM. Well, here's L, there's J, and there's M. So I just created 2 vertical angles. They share a vertex. They have 2 lines that are intersecting, and we have this opposite angle over here. We know that vertical angles are congruent, so that means it must be 85 degrees. Ladies and gentlemen, we have 4 quick examples to move before we move on to our second video. Tell whether the angles are adjacent or vertical, and then find the value of x. And so here we have 2 angles. There's a vertex right here, and they happen to share this one side. So we have adjacent angles. All right. And now I want to find the value of x. Hopefully you recognize that adjacent angles do create these 2 adjacent angles. Not all, but these 2 happen to create that straight angle. A straight angle is half a circle, which means it's a semicircle, but half a circle is 180 degrees. So I have to know that x plus the 32 has to equal 180. And when I subtract the 32 from both sides, I get x equals 148 degrees. Very nice. Moving right along to example 4. Example 4, I have 2 intersecting lines. There is a vertex there, but they've marked this one up here, 142, and they marked this one down here. Those are opposite angles. Opposite angles are vertical when they share a vertex. And I know that vertical angles are congruent, so I know that x has to equal 142 degrees. Nice. Continuing on with example 5, here I have 2 angles. These 2 angles share a vertex and a side. They also form this thing right here. But with sharing the vertex and the side, let's go ahead and label it. That, of course, would be adjacent again. And that box that I was highlighting, let's make it red. That box that I was highlighting, what does that indicate? That's right, a right angle. And a right angle is is 90 degrees. A right angle is 90 degrees. So I know that this 3x plus the 2x has to equal 90 degrees. 5x equals 90 degrees, so x has to equal 18 degrees. Nice. Ladies and gentlemen, moving right along with our next example and our last one of the night, we have, this is a tricky one. A lot of people get confused on this one. Here's the vertex formed by two intersecting lines, and when you see this up here and this down here, you're instantly going to jump to vertical. However, what is that arrow showing us? Oh, it's showing us that they're moving that x minus 2 degrees actually represents this angle here. So we have, again, adjacent angles. A-D-A-G, A-C-E. Adjacent angles. Sometimes I have trouble spelling. And we know that those two adjacent angles happen to form this one line right here, which we talked about in example number 3 as being a straight angle, which is 180 degrees. So I know that angle 6x plus angle x minus 2 has to equal 180. So I know 7x has to equal 182. That means x is 26 degrees. So these are adjacent. Don't let that trick you. Pay attention to the arrow, because at just a quick glance, you would instantly go that they are vertical. And that's not necessarily true. Okay? Ladies and gentlemen, our first quick ride of the night. Tell whether these angles are adjacent or vertical, and then find the value of x. Please copy down the angles, label them correctly, and then complete your quick ride. Get a quick snack. Hey, text your friends and tell them about adjacent and vertical angles before you come back to video 2.